So the next question is, how well does the model fit the data? Now, as a challenge, do you remember how to print out a regression's R-squared value from the previous lessons? I want you to print out two different R-squared values. I want you to print out the R-squared value for the training dataset and the R-squared value for the testing dataset. I'll give you a few seconds to pause the video and give this a shot. And here's the solution. To obtain the R-squared, we access it through the regression object's score method. So my first print statement is going to read training data R-squared colon comma regr dot score parentheses x underscore train comma y underscore train. So this will be the R-squared of the training data set. And the R-squared of the testing data set will be test data R-squared colon comma regr dot score parentheses x underscore test comma y underscore test. So let's take a look at what these turn out to be. For our training data, we get an R-squared of 0.75. And for our test dataset, we get an R-squared of 0.67. Now, these values are actually both quite high. I mean, when you think about it, the real world is a very, very complicated place. But we've been able to explain approximately 75% of the variance in our house prices with just 13 features, 13 things, and we can explain a lot of what's going on in the real world. Now, a question that you might ask looking at these two values is, why is the R-squared lower for the test dataset? And the answer is that what we've done so far is calculate the thetas only on our training data. The algorithm hasn't seen the test data before. As such, the performance of our model on the data that the model hasn't seen is always going to be worse. It makes sense for the R-squared to be lower on the test data than on the training data. However, running the model on data that's not in the sample actually gives us some idea of its predictive power. We get a little bit of a feeling for how our model would fare in the real world. And it's very encouraging to see that the R-squared, even on the test data, is still quite high. So our model actually performs relatively well. Okay, so we've spec'd out our model and we've run our first regression. We did a quick sense check and looked at the performance. Now we're getting to the evaluation stage. Now, before we move on to the next lesson, let's add another markdown cell above this one here and add the section heading multivariable regression. That way we can keep track of what we're doing. The other thing I'm going to do is take these two lines of code, cut them, and paste them down here. That way, when I hit Shift Enter, we'll be able to see our data frame of coefficients. Otherwise, the output is hidden by the print statements. There we go. Now we're ready to move on. I'll see you in the next lessons.